Hello, Geometry Classes. Martin here. Hopefully everyone's doing well, everyone's staying safe, and everyone's getting some time outside with the nice weather that we've had over the last couple days or week or so at this point. But I wanted to kind of give you a quick overview of this week, and then we'll talk about what we're going to be going over for content. So today's Monday. Watch the video, comment on the video, either YouTube, Canvas, or email me a comment so I can know that you watched the video. Tuesday, same deal. Gonna put out another video. Comment on the video so you can get credit to either YouTube, Canvas, or email. Wednesday, I have packet work for you to do. Get the packet work done. Get it back to me. If you have questions, email me. Let me know. I'd love to talk to you. Love to work through it. We could set up a Google Hangout or something if you need support with the packet. Thursday is makeup day. Use that time to make up any work that you have missed. Past weeks, this week, whenever. Please reach out if you are confused on what to do. I can show you. I can point you in the right direction. I can give you some work that you owe. And then on Fridays, our social emotional day, where Mr. Bergenholtz and Mr. Nelson will be holding Google Hangouts for twice during the day, and then same thing with Ms. Johnson, Ms. Armistead. So please reach out to them, let them know whether you're going to be attending. You don't have to, you can pop in, but they'd love to see you. We'd all love to see you. Over the last couple of weeks, a few students have joined the Hangout, so it's good to see everyone. And then also you guys get to see each other. We have great relationships with all of you. We want to kind of keep those relationships going. Okay, I know it's a tough time. It's difficult not being around your friends, not being around the people that you've created relationships at school. But this is one way one thing that we're doing to kind of support you through this time. So, geometry. Let's take a look up here. We're continuing with triangles, right triangles more specifically. I want to review one thing. We'll then talk about the learning objective. So first thing, isosceles triangles. Isosceles triangles are triangles that have two equal sides, and with those two equal sides, they have two equal base angles. So they have two sides the same and one side different. Same thing with the angles. They have two angles the same, one angle different. So with that being said, learning objectives, students will be able to recognize patterns in a 45, 45, 90 triangle. I guess I should put recognize side length patterns. We're going to be focusing on the sides, okay, on a 45, 45, 90 triangle. So let's look at this and let's figure out our missing sides, starting here. We know this is 45, 45, 90 because it's an isosceles triangle. We have two sides the same, right here and right here, which means that these angles here and here are going to be the same. I know that this one's 90, so these ones have to be 45 and 45. All right? So anytime you see these two little marks and a 90-degree angle, you know you have a 45, 45, 90 triangle. Or if you see these two little marks, you don't see a 90-degree angle, but you see a 45-degree angle, you know it's a 45, 45, 90. With this being a right triangle, we can solve for my hypotenuse or my C value, this is my C, using my Pythagorean theorem. A squared plus B squared equals C squared. So 3 squared plus 3 squared equals C squared. 3 squared is 9, so 9 plus 9 equals C squared. 9 plus 9 is 18 equals C squared. Am I done? No, not quite done yet. Now I got to square root the whole thing because I want to know what C is, not what C squared. Square root, and I say the square root of 18 equals C squared. Now we're going to simplify. We did this earlier in the year. We did it last year. Let's break it down. I want to say what two numbers can give me 18. I'll start with 2. 2 times what gives me 18? 2 times 9. All right. Now I can break down 9. What two numbers give me 9? A 3 and a 3. Great. Anytime I have a pair, I can circle that pair and take that number out of my radical. So when I do that, I take out the 3 and I put the square root sign, and then I leave whatever I didn't take out underneath. 3 square root 2. That's my simplified version of C. So this is 3 square root 2. Okay. I'm looking at it. I want to look at any patterns I see here. I'm just going to write this in a different color, kind of so we don't get confused. Oh, no, it doesn't work. Ooh, that's not great either. So 3 square root 2 right there. All right. I see some 3s. I don't know about the square root 2. I see some pattern going on here. There are lots of 3s over there. Let's take a look at the next problem. Let's see if we can recognize a pattern between this one and this one once I find my missing sides. So let's start with what this side would be. All right. I know I have a 45, 45, 90 because I have my 90 degrees here, and then I have two sides that are the same, so this would have to be a 45. So I say, okay, this is 5. This one also has to be 5 because the dash mark tells me that they're equal. So let's go and use our Pythagorean theorem. 5 squared plus 5 squared equals c squared. There's my c value. 5 squared, 5 times 5 is 25. So 25 plus 25 equals c squared. 25 plus 25 is just 50 equals c squared. Now find the square root, and let's simplify. So I take the 50 and I say, what two numbers multiplied together give me 50? All right, so 10 times 5 gives me 50. Great. Now I can't simplify the 5 because it's only 5 times 1, 5, and those are the only factors. What are my factors of 10? 5 and 2. All right, and that's as far as I can go with this. Now, do I have any pairs of numbers? I do. I have a 5 and I have a 5. So I can take the 5 out and put the square root and then leave whatever's left underneath, 5 square root 2. Great. So my c value over here is 5 square root 2. Okay, now I've done 2 of these problems. I take a look and I say, what kind of patterns can I recognize here? Okay, so this one is 3, 3 for the 2 sides, for the 2 legs, and then 3 square root 2. All right, I see the 3's and then there's a square root 2. This one is 5, 5, and then 5 square root 2. Okay, I see a pattern now emerging. All sides have a 5, or all sides have a 3, except the longest side, the hypotenuse, has that side with the square root of 2. Now, let me write this rule so we can take a look at it and we can understand it and we can utilize it moving forward to find the lengths of the sides of a isosceles right triangle. Okay, so we'll call 45, 45, 90. We're going to call these two sides x, x and x, and then whatever those sides are, this is going to be x times the square root of 2, all right? So what that tells me is if I'm going to use this kind of formula moving forward, there are 2 types of problems I'm going to see here. The first one is very similar to the ones that we just did, where you're going to have this, and you know, because you have the 2 sides that are equal and the 90 degrees here, and I want to find my other 2 sides, and one side is 12 here. Okay, if I equate this to this formula over here, I say This is 12. This would also have to be 12, okay, because these two sides are the same. And then this side over here is going to be the same times the square root of 2. 12 square root of 2. Oh, that's pretty simple, right? You see 12, 12, 12 square root 2. 45, 45, 90 triangle. Take a look at one more problem. And we're gonna change it up just a little bit, make it a little bit, maybe not more difficult word, but just a little different, maybe throw away. Let's go with 7 square root 2, okay? I'm giving you the hypotenuse. Figure out the other two sides. Ooh, before we do that, 90. So we know it's a 45, 45, 90. These two sides are going to be the same, and here's my hypotenuse. Okay, how do I go ahead and figure this out? Well, I take a look here, and I say, if this one was x square root 2, for these two sides, all you're doing is taking away the square root 2, and just whatever that x value is. In this case, it's 7. So you have just a 7 here, and a 7 here. And that's your answer, okay? Those are your two sides 7. All right, I think that's enough of 45, 45, 90s for today. The next video we're going to do, tomorrow's video, is going to be on a 30, 60, 90, which is a little bit more difficult, but it follows that same kind of pattern. We're going to take a look at a few, and then we'll see what we can do to figure out a pattern of them. Other than that, comment on the video. Please let me know how I'm doing, how you're doing, how this whole virtual learning thing's treating you. All right, we'd love to hear from you.